So in this video, I'll discuss the Hund's rules. Okay, so take note na minsan Hund's rule lang ang tawag dito. So yung Hund's rule, that's the overall rule on how you put electrons in each orbital for each subshell. Okay, so dinivide ko sa tatlong rules to para ma-feature ko yung properties ng bawat isang rule. Okay, so for the first Hund's rule, electrons in the same orbital must be antiparallel. So this follows the Pauli's exclusion principle. So, tingnan muna natin kung ano yung mga possible spins ng electron sa atom. So, we have the spin up or the plus 1/2 m sub s. We have the spin down or the negative 1/2 m sub s for the electron. So, according to this rule, kapag parallel spins, pareho sila ng spin orientation, pareho silang 1/2 or pareho silang plus 1/2 or negative 1/2. So, this is not allowed according to the Pauli's exclusion principle and the first Hund's rule. Dapat sila ay antiparallel kung nasa isang orbital lang sila. Okay? So for example, we have the orbital diagram for argon. So this is how you write the orbital diagram. So sa bawat isang subshell, meron tayong orbital. So for 1s, we have 2 electrons in the orbital. For 2s, we have 2 electrons. Okay? So sa 2p, meron tayong tatlong orbitals. Okay? And we have 2 electrons per orbital na puro antiparallel to each other. So for 3s, again, we have 2 electrons. And then finally, we have 3p na may tigda dalawang electrons. Okay? So, ganyan yung Hund's rule na una or yung first Hund's rule. So, for the second one, the configuration with the highest number of unpaired electrons is preferred. Ito yung sa mga partially filled subshells. Okay? So, this is due to the so-called multiplicity of states. So, sinasabi nito na kapag mas mataas yung number of unpaired electron for a partially filled orbital subshell, mas mataas yung multiplicity, therefore, mas mababa yung energy ng state. So, pinaprefer ng ating atom na mababa lang yung mga energies. Kasi pag mataas ang energies, mas unstable siya. Okay? So, for example, what would be the preferred electron configuration or electron distribution for the 2p subshell kung meron siyang tatlong electrons? Okay? So, yung una, meron siyang paired, tapos meron siyang isang unpaired. So, mataas ang energy nito kasi isa lang yung unpaired. So, for 3 electrons na nasa tatlong orbitals, dapat tigi-isang unpaired na lang. Yun yung maximum. So, ito yung dalawang examples. Okay? So, makikita nyo na yung isa ay naka-antiparallel with respect to the other two. Tapos, dito naman, lahat ng spins niya ay parallel. Okay? So, ano kaya yung mas preferred? So, then we have rule number 3. So, sa rule number 3, the configuration with the most number of parallel spins is preferred. So, ibig sabihin, ito yung preferred. Okay? So, for example, in this orbital, makikita nyo na ito yung pinakamarami yung parallel spins. Okay? So, dito, meron tayong isang antiparallel. So, yung dalawa lang yung parallel with each other. So, dito, lahat ng spins ay parallel. So, ito yung preferred. Actually, ito rin ay preferred. Pero, due to convention, inuuna natin yung mga spin up. So, pag maglalagay kayo ng electrons sa mga orbitals, you do it like this. So, if you have 3 orbitals, okay, ilalagay nyo muna lahat ng spin up. So, if this is 2p6, ilalagay nyo muna lahat ng spin up. Okay, na paganyan. And then, tsaka nyo ilalagay yung tatlong spin down. So, ganyan tayo mag-fill out ng ating orbital diagram. Okay? So, regardless of the subshell, ganyan dapat yung gagawin natin. So, singly filled muna sila. So, isa-isa muna, tagi-isa mo ng parallel spins and then ilalagay mo yung kanilang antiparallel spins kapag napuno na natin yung subshell or kapag may tagi-isa na siyang electrons. Okay? So, what is the reason for this? So, we have energies due to configuration. Okay? So, for the energies, we have two types. We have exchange energy and Coulombic energy. So, exchange energy is the energy that is needed to change the spin orientation. Okay? Kapag change mo yung spin orientation, magiging distinguishable na yung mga electrons with respect to each other. So, malalaman mo na kung alin yung mga electrons. And this is actually making the configuration more unstable. Kasi yung indistinguishability actually is the one that is making it more stable. Kapag hindi mo ma-distinguish yung dalawang electrons. Okay? So, ibig sabihin kasi mayroon siyang dalawang states na possible. So, pwede itong magpalit nang hindi mo napapansin kasi hindi naman sila distinguishable. Pero kung papalitan mo yung isa ng spin, madidistinguish mo na sila kapag nagpalit sila. Okay? So, that kind of distinguishability increases the energy. Okay? So, we also have the Coulombic energy. So, that's the energy needed to surpass the electron-electron repulsion. So, pag pinaglapit mo yung dalawang electron, nilagay mo sila sa isang orbital, okay? Meron ka dapat na isurpass na electron-electron repulsion energy kasi paglalapitin mo yung dalawang electrons. So, kailangan mong isurpass yung tinatawag nating Coulombic energy. So, if you have this configuration, dalawang parallel spins na nasa tig-isang orbital, kapag in-apply mo siya ng exchange energy, mas magiging unstable siya kasi nagiging distinguishable na yung electrons, okay, with each other. Tapos, kapag in-apply mo ng Coulombic energy, pwede mo na siyang paglapitin. This is the most unstable kasi siya yung pinaka-energetic na state. Ito yung least energetic state, therefore, ito usually yung preferred na state kapag meron kang dalawang electron sa dalawang orbitals na separate. Okay? Mas prefer nila na tag-isa sila tapos parallel yung spins. Okay? So, from the most stable configuration, magiging least stable configuration kasi nag-apply tayo ng mga energies. Okay? So, we also have the so-called subshell symmetry. So, na-observe nila na half-filled and fully filled subshells are more stable than other partially filled subshells. Okay? So, ano ibig sabihin ng half-filled tsaka fully filled? So, if you can observe here, okay, meron tayong 2p3 tsaka 2p6. So, sa 2p3, meron tayong tigi-isang unpaired electron sa bawat isang orbital ng 2p subshell. So, dito rin sa 2p6, meron tayong tigda-dalawa naman. So, evenly distributed yung electrons doon sa mga orbitals ng subshell na to. So, that is the orbital subshell symmetry. Okay? So, kung evenly distributed yung charge, magkakaroon tayo ng parang stability, extra stability due to the symmetry. Okay? So, what are the evidences or what are the consequences of this subshell symmetry? So, for the first one, nitrogen is more difficult to ionize than oxygen, even though oxygen has a higher Z. So, mas maraming protons yung oxygen, so dapat yung mga electrons niya mas mahirap i-ionize due to the attraction between the protons and the electron. Pero, due to the subshell symmetry of nitrogen, mas mahirap i-ionize yung nitrogen 2p electrons. Okay? So, makikita natin dito na merong subshell symmetry yung 2p, tapos walang subshell symmetry yung oxygen. Kahit mataas yung Z ng oxygen compared sa nitrogen, mas mahirap i-ionize yung electrons ng nitrogen because of this extra stability. Okay? So, we also have the stability of the noble gases, di ba? So, meron tayong tinatawag na octet rule. So, yung octet rule, this is due to the subshell symmetry of the 2p and the 2s. Okay? So, pareho silang n equals 2. So, yung 2s mo ay fully filled, yung 2p mo ay fully filled din. So, evenly distributed yung mga electrons throughout each subshell. Okay? So, ganun din sa argon, tsaka sa iba pang noble gases. Okay? So, another evidence is yung electron configurations na nag-a-adjust para makasunod tayo dun sa orbital subshell symmetry. So, yung mga electron configurations na ns2, n-1, d4, usually nagiging ns1, n-1, d5. So, yun yung case ng chromium. Okay? So, yung chromium is 4s2, 3d4. Okay? So, from 4s2, 3d4, ang na-observe nila, nagiging 4s1, 3d5 yung ating chromium. So, that is because yung 4s2, 3d4, pag tinignan nyo yung 3d, hindi siya symmetric. Hindi evenly distributed yung mga charges dun sa orbitals. Pero kapag naging 4s1, 3d5, kakaroon na siya ng symmetry. Nagiging evenly distributed na yung mga charges dun sa 3d. Tapos, half-filled yung 4s. So, may symmetry pa din siya. Okay? So, the spin symmetry of both 4s and 3d subshells are attained. So, nagkakaroon ka ng extra stability. So, bukod dun, na ma-maximize din yung multiplicity. So, it adds to the stability factor for this configuration ng chromium. Okay? So, finally, we have electron configurations ns2, n-1, d9, nagiging ns1, n-1, d10. So, that's the case for copper. So, yung copper, ganito yung electron configuration niya kapag isusulat nyo kasi that's 4s2, 3d9. Pero na-observe nila, nagiging 4s1, 3d10. So, kapag yung electron ng 4s na to nilagay mo doon, nagiging symmetric pareho yung kanilang subshells with respect to the charge. Okay? So, nagiging fully filled yung 3D, nagiging half filled yung 4S. Okay? So, na-attain yung spin symmetry or yung orbital subshell symmetry ng 4S and 3D. So, the spin angular momentum is also maximized kasi mas mataas yung spin angular momentum ng nasa 4S kasi yan ay n equals 4. N equals 3 lang yung 3D. Okay? So, yung spin angular momentum nito is greater than the spin angular momentum of the 3D unpaired electron. Okay? So finally, we have the magnetic susceptibility. So magnetic susceptibility is the ability of your atom or element to interact with magnetic fields due to its electronic structure. Okay? So since electrons are moving charges, they interact with magnetic fields. So we have two types, paramagnetic elements and diamagnetic elements. Yung paramagnetic, ibig sabihin no, nag-interact siya sa magnetic field. due to its unpaired electrons. So kapag may unpaired electrons ang iyong atom, okay, ibig sabihin meron tayong net magnetic moment. Hindi siya nakakancel ng antiparallel spin. Okay, kasi wala siyang ka-pair. Okay? So, yun ay paramagnetic. Kapag diamagnetic naman, lahat ng electrons doon sa inyong electronic structure or doon sa atom mo ay paired. So, cancel yung kanilang magnetic moment. So, hindi nag-interact sa magnetic field yung mga ganitong elements. Okay? So, to be able to evaluate the magnetic moment, we have the spin-only magnetic moment equation. So, mu sub s, that's the spin magnetic moment, is equal to the Bohr magneton times the square root of the quantity s times s plus 2, where s is the number of unpaired electrons. Okay? So, yung Bohr magneton natin ay 9.27 times 10 to the negative 24 joules per Tesla. Okay? So, for example, we have the element technetium. So, calculate natin yung spin-only magnetic moment ng technetium. So, for technetium, we have Z equals 42. Yung kanyang electronic configuration ay krypton 5s245. So, alam naman natin na fully filled na yung krypton, so wala siyang net magnetic moment. So, ito na lang yung ating isusulat na orbital diagram. So, we have 5s na paired, and then we have 4d na may 5 unpaired electrons. Okay? So, ibig sabihin paramagnetic to. Marami siyang unpaired electrons. So, to calculate the mu s, okay, we use the number of unpaired electrons. So, that's mu s is equal to the Bohr magneton times square root of 5 times 7. So, that's equal to 5.92 times the Bohr magneton, which is equal to 5.48 times 10 to the negative 23 joules per Tesla. So, since may value siya ng mu sub s, ibig sabihin siya ay paramagnetic. Kaya siya may value ng mu sub s kasi meron siyang unpaired electrons. Okay? So, for cadmium naman, since cadmium is krypton 5s2,4d10, wala tayong nakikita ditong unpaired electrons. So, wala tayong maisusulat na unpaired electron number. So, s is equal to 0. Okay? So, therefore, the mu sub s is 0. Therefore, cadmium is diamagnetic. Okay? So, this is my discussion on Hund's rule. So, mag-proceed ako sa the elements of the periodic table, tsaka periodic trends, tsaka yun sa effective nuclear charge sa susunod na video. So, see you next video.